Okay, let's discuss example 14. A 10 kilogram box is pulled along a horizontal smooth surface by a force Fp is equal to 40 Newton, applied at a 30-degree angle above horizontal. Calculate the acceleration of the box and the magnitude of normal force exerted by the table on the box. Okay, so we have a box here is put on a table and we have external force is pulling this box towards this direction. So meaning that we have acceleration. So the acceleration will be going towards this direction. And then this external force is being pulled at 30-degree angle. Okay, so this is exactly like Newton's first law, except that now we have acceleration. Okay, so you need to identify which way is the acceleration, because we know that there is external force pulling towards this direction, so we know the acceleration is going to the right. Okay, so first thing to do, we identify the forces. Okay, macam biasa, we have weight force going downward, and then since it is on a table, we have normal force, and then external force, and that's it. The surface is smooth, so we don't have any friction. Okay, so now let's draw the FBD. Okay, so when you draw FBD, make sure you draw the X and Y axis in dotted line, because we don't want to mistake it as a force. Okay, so now, okay, wait, I forgot to put here. Okay, so we have normal force. Okay, don't forget to put a dot, and then weight force going downward, and then external force FP with 30-degree angle, and the acceleration is going to the right. Okay, so why it's important to label the acceleration here? Because we want to know acceleration, is it on the y-axis or on the x-axis? Okay, so next one, we will transfer the information into a table. So we have normal force, external force. Okay, wait, this one should be FP, because it's they gave you the label already, so you need to follow the label. And then we have weight force, and the last one is the sum of the force. Okay, so now and this one will be positive. Force, since it is here to the right going upwards, so both are positive. So FP is 40 cos 30, while here 40 sine 30, and weight is going downward, will be negative mg. So m is this one times with g. Okay, and then you need to be careful here, because it's no longer the same as first law. Now we are having the acceleration. Okay, acceleration. So kita kena make sure acceleration tu dekat axis mana, component yang mana. Okay, that's why apabila kita label it is going to the right, meaning that it is on the x component. So the sum here must be equal to ma. Okay, because dekat x component ada acceleration, because the box is pulled along a horizontal smooth surface. Dia bukan ditarik ke atas. Okay, dia ditarik ke kanan, because we have external force here. So on the x component we have ma, but on the y component, because there is no motion here, so y component will be equal to 0. So the next step, macam biasa, kita akan tambah semua and then equal to this. This one pun sama. So the sum of fx is now equal to ma. Di mana fx, we have 40 cos 30. This one kosong, you just leave it like that. equal to MA, di mana M adalah 10 times width A, and then we can get the A is equal to 3.46 meter per second squared. Okay, don't forget for acceleration, it is meter per second squared. Okay, so that one is for question A. We need to find the acceleration, and then next one we need to find the normal force. Okay, the value for the N. So we have 40 sine 30 plus N minus 10 times 9.81. Okay, equal to 0. So you will get the value for N is equal to 78.1 Newton. Okay, next one, example 15. A 10 kg box is pulled along a horizontal surface by a force Fp of 40 Newton, applied at 30-degree angle above the horizontal. So this is like example 14. Okay, not 16, 14. Except now we have friction and we assume a coefficient of kinetic friction is 0.3. Calculate the acceleration. So this is the same as example 15, but now we have friction, which we are given the coefficient of kinetic friction 0.3. Okay, so we have this value now 0.3. Okay, since soalan ni sama dengan example 14, so I just copy the solution, except that now we need to add the friction. Okay, so on the FBD, since the motion is going to the right, so the friction will be opposite direction. She's going to the left. So we have friction force now. Okay, so dalam jadual pun kena tambah friction force. Okay, since we know that friction force is equal to mu K times with normal force. Okay, it is going to the left, so it is negative 0.3 N. And then this one will be 0. So yang lain sama. On the X component we have MA, Y component equal to 0. Okay, so now we only want to have, we need to find acceleration, which is kita hanya kena kira dekat X component saja. Okay, so Fx is equal to MA. Okay, so since dekat soalan example 14 tadi kita sudah kira N kan, so let's just take that one. Okay, 78.1 Newton. So here kita just masukkanlah 78. So kita anggap kita sudah dibagilah value normal ni, normal force. So masukkan. So it will be 40 cos 30 minus 0.3 times with 78.1. Okay, wait. Okay, equal to MA. M is 10A. Okay, so benda yang sama except that now we have the friction force here. So A will be equal to 1.12 meter per second squared.